Alright, example number 3. Graph the following by first converting to vertex form and then using mapping notation. A lot of you guys might feel that it might be useless to convert to vertex form. Why not to graph something? Won't I just choose random values and make a table of values, like plug in -2, -1, 0, 1, and 2? Now the problem with that is you're going to get, if you try that, you're going to get part of the parabola that could be just like this, 1, 2, 3, 4, 5, 6, and you're not going to get the vertex per se. You're just going to get 6 points in a row, but not necessarily find the vertex. Okay, so it's important to convert to vertex form first, and then use mapping notation, because you'll always get the most important points of the parabola, and find the transformed new points of the parabola that correspond to that vertex. So, how do we convert to vertex form? First thing you have to do is you have to factor out this a value from both these first two terms. So you're going to divide out by 1/3. Dividing by 1/3, it's going to give us x squared here. 6 divided by 1/3 is the same thing as multiplying by 3. So that's going to be 18x. And I'm going to leave the last term to be plus 1 here. And now we're very close to getting vertex form. We just have to do some tricks in order to get that this binomial squared here. And you can always check to see if this does equal this. So if I were to multiply this back in, 1/3 times x squared, this gives me 1/3 x squared. If I multiply 1/3 times 18, 1/3 of 18 is going to be 6x. So yes, this is going to be the same as the standard form so far. Now, the next thing is to make this a perfect square trinomial. And to do that, we take this 18, we half it, and then we square it. So half of 18 is going to be 9. We square it, it becomes 81. So this number that we got, which is 81, we are going to add and subtract that 81 right here inside the brackets. And by doing so, we can get a perfect square trinomial. Now the goal is to get a trinomial. Right now I don't have a trinomial in here. We have 4 terms. We have to get rid of that 4th term by distributing that 1/3 only to that last term, so we can maintain this perfect square trinomial inside these brackets here. So we have to take 1/3 of 81. So take 81 times divided by 3. Give me 27. Minus 27 plus 1. And we're going to have to factor this. So find two numbers that multiply to 81 and add to 18. So that's going to be 9. And again, you can always use a trick and remember that this value here is half of 18, and 9 squared will also give you 81. So that number will always appear in the final form of the factored form of the perfect square trinomial. And now we simplify this. Negative 27 plus 1 is going to be minus 26. And so now I know that this drawing of mine was wrong. I now know that this parabola is at negative 9. The vertex is at negative 9. So negative 9 and negative 26. And we know it's opening up. It's going to look something like that. So the vertex is around here. This is just sketching, but they want the graph, so we need exact points. I can't just do this. I need exact points. They want 5 good points when they're asking us to graph. I have only found 1 good point. So going back to my original statement, Mr. Shin, we can always just graph by plugging in random values like -2, -1, 0, 1, and 2. If you plug in -2 for x, -1, 0, 1, and 2, you're just going to get these 5 points, 1, 2, 3, 4, 5. You're not going to get the most important point, which is -9 and negative 26. You're going to be guessing. You can't tell what the vertex is from standard form. You have to do some work to find out what it is. Now this, if you recall, we can identify our a, h, and k values. So let's write out the general form for vertex form. And the first thing you should notice is that this is actually not in proper vertex form. Why, might you ask? It's because of this. Oopsies. It's the plus and minus sign here. In vertex form, it requires a negative sign to be here. So it's not perfectly in vertex form. So the h value is actually not corresponding yet. We have to do some work in order to get and extract the proper h value. So to do that, we're going to make a negative sign here. So I'm going to go from here to here. Y equals 1/3, and this should be an x minus. Now these two statements should be equivalent because otherwise they're not equal. I'm writing them below each other because they're equal. So for a positive sign is equal to two negative signs. So we can write two negative signs here. And this is equivalent to each other now. I have not changed the parabola or the quadratic. And what this enables me to do is extract the h value properly. We know the a value, which is easy, that's 1/3. The h value, not that there's a minus sign, the h value itself, I'm going to probably put this in a different color. H value itself is going to be -9. So h equals -9, and k is -26. And from here, we can now use the mapping notation. So this represents every single x and y coordinate. It's going to be mapped onto a new, or going to be transformed according to these parameters here. So all the x values are going to be adding the h parameter. All the y values will be multiplied by a, which is your vertical stretch or compression. And it'll be added by the vertical shift here. And we can now just add h, which in this case is going to be -9, which makes sense because we're taking that original parabola and subtracting it to the 9. We're shifting it to the left by 9. Then we're going to compress it by 1/3. And we are going to subtract 26 because that's what k is. And from here, we can actually get the actual points of the new parabola. So let's generate the x and y coordinates of the parent parabola. So we can choose any values of x. We can choose these easy values. And from here, we know how y corresponds to x. It takes the x values and squares them. So we're going to take x -2 and square it, which becomes 4. -1 squared will be 1. 0 squared will be 0. 1 squared will be 1. 2 squared will be 4. And all these points will be transformed according to this. We're going to take every x value and subtract 9 because it's going to be shifted to the left by 9. So -2 minus 9 will be -11. -1 minus 9 will be -10. 0 minus 9 will be -9. 1 minus 9 will be -8. 2 minus 9 will be -7. And y here is going to be affected by this vertical compression, and then shift it down by 26. So we're going to take every y value, divide by 3, so 4 divided by 3, and subtract 26, which gives me 24.6, repeating. Then we're going to take 1 divided by 3 minus 26, which is -25.6, repeating. Looks like my drawing is... So this corresponds, and we can plug in 0 now. So y value is 0, so 1/3 times 0 minus 26 will be -26, and that is the vertex. And the remaining two will be identical to the one above because the parabola is symmetric. Okay, so this question originally asked us to take this standard form and convert to vertex form. And to convert things to vertex form, we did something called completing the square. And we completed the square in these first 4 steps. So let's label that complete square. And after we completed the square, we made sure that it was in the proper vertex form with that negative sign, and then we extracted the correct a, h, and k values, used those a, h, and k values in our mapping notation to determine how those x and y coordinates were changed. In this case, the x values were shifted to the left by 9, and the y values were compressed by 1/3 and shifted down by 26. Okay? If there's any questions, please email me and see me or talk to me on Google Chat. Take care.